remembers what terminating means? Tatum? It does not repeat. I mean, that's a true statement, but there's something more to it. It stops. Okay, so if I terminate the conversation with you, that means we're stopping the conversation. That's what terminate would mean. Okay, so we look for the numbers that stop. The numbers that stop up here would be this one. It stops after the 4. It's not going on any further. And this one. It doesn't matter how long they are. As long as they eventually stop, that's terminating. We have noticed in digits, because a couple kids showed me, this means that it is non-terminating, but it continues to go on forever. That's the way digits language is saying it, okay? So same thing here. This is saying it's not terminating. They would use the bar notation, but it's going on forever. Okay? All right, next one. Circle the fractions that can be written as a terminating decimal. So you would have to get out your calculator, and you would have to calculate these. Let's remind you how to do that. How do you change a fraction into a decimal? Yes, so you're going to take 7 divided by 12 and then put the 8 in front of it. Very good. Okay, so which ones of these are, what does it say, terminating? Which ones basically stop? Justin?
The 19, 12, 25, over 25.
Okay, and is there another one? That's it? That's the only one? I'm going to trust you guys. Check them all? Okay. All right, what is the decimal equivalent of 8 1/5? Kendall? 8.2. Very good. So again, if you take 1 divided by 5, your calculator is going to say 0.2, and then you add that 8 in front of it. Okay? All right, and the next one. Why isn't 4.671 and all those zeros a terminating decimal? Okay, the bar does mean that. They're looking for something a little bit else, because look at all those zeros. Yes? Zero doesn't affect the number, so which number makes this one tricky? Jenna? Okay, but if they would have written it like this, they're trying to get at something a little bit. Is that terminating? Yes, it is. Yeah, that would be terminating. Yes. The 1. You can have as many zeros as you want after it. Zeros after it do not change it. 0.8 and 0.80 are the same number. Does that make sense? I can put as many zeros as I want. So they were trying to trick you to say, hey, look, I'm just doing zeros, but the tricky number is the 1. Each time this is going to go 1 and then 4 zeros and then another 1 and 4 more zeros. So that's what they were trying to get you to see. Okay? Even though I think that's a little tricky. Okay, any questions on any of that before we move on? No, this one isn't terminating. It is repeating because of that 1 right there before the zeros. Okay. All right, so let's look at our learning goal for today. The students will understand how to convert and solve problems involving fractions, decimals, and percents. So I've already taught you how to take a fraction to a decimal. Now we're going to take it to a percent, and then we're also going to go backwards with it. It will be the new stuff we look at. Okay, so I wanted to make sure you understand that this all still falls under rational numbers. Remember, rational numbers are anything that can be written as a fraction. Anything that can be written as a fraction is a rational number, which means that there are any number, that's what we just said, can be written as a fraction. All fractions can be written as decimals, and all fractions and decimals can be written as percents. They're all still rational numbers. Okay, everything still falls under that category. All right, so with that said, we're going to look at this chart and we're going to fill in the different types of numbers here. So we're good at the first one. If we have a fraction 3/4, how do we change that to a decimal? Very good. And what would 3 divided by 4 be? Okay, you can either put 0.75 or if you like to have a 0.75, those are both the exact same. I usually don't write the extra 0. Okay, how would we change that decimal into a percentage? This is real life. If you got a 3 out of 4 points on an assignment and you wanted to know what the percentage was, Justin?
Move the decimal over twice to the right.
Very good. So I'm going to write that here. Move a decimal, 0.12, we need to change that into a percentage. So I need to move the decimal 2 times. And what percentage is that going to give me? 12%. Very good. Okay, now we have to be able to write that as a fraction. So how would I write that as a fraction? All right, who knows? How do I change it to a fraction? I know a couple of you know. I know some of you know. No one? Dominic? Kendall? No? Not to change to a fraction. Okay, what are percentages always out of? 100. So I could write 12 over 100. That's one way to do it. Or your 6th grade teacher should have taught you, what place value is that?
Tens.
Tenths. What place value is this? Hundreds. So how do you truly read this number? 12 hundredths. Isn't that what this is? 12 hundredths. That's the same thing. Okay. So then I'd have to put it in simplest form. So what would 12 and 100 both divide by? 10 will go to 2. So 12 divided by 2 is 6. 100 divided by 2 is 50. There was a bigger one. So that will still reduce, right? 3 over 25. Okay. So what was the number that would have gone into? Yeah, 4 would have gone into 12 and 100. Okay. All right. So let's look at the next one. How am I going to change this percentage back to a decimal? Dominic. To the left. It's just the opposite, right? If this is moving it to the right, then now I want to move it to the left. So the decimal point's right here, and move it 2 times. So I get 1.75. Okay, how do I change that into a fraction? Kathy? And then 75 over 100. Okay, I heard somebody else already knows. If you know you have 75 over 100, you probably know that's the same thing as 3/4. But I'm just reducing it, so it would be 1 3/4. All right, last one. This one's kind of tricky. How do I change this decimal into a percent? Yeah, you still move it over 2 times, right? It's the exact same rules. So I'm going to move this over once, twice, and I get 0.6 or 0.6%. It is okay to have a very small percentage. We're going to look at that in, I think, the next lesson or coming up. It's okay to have a small percentage. Okay, now this is where it gets a little tricky. How do I change that into a fraction? Kathy? Okay, how'd you get over 1,000? I agree. Because it's in the thousands place. Very good. So look at your decimal. This would be tenths, hundredths, thousands. So that's why it's over 1,000. Can that reduce? Yes. 3 over 500. Good. Okay. Any questions on that side before we keep going? Yes. No, because it's 0.6. Okay, this is a decimal. This is because I'm talking about a decimal or a percentage. If this is in its decimal form, then that means it's 80%. This is its decimal form. This is its percentage form. Does that make sense? That's confusing. Okay. How do I what? I know my multiplication tables really well. Yeah. Well, I mean, like, right now my 3rd grader's learning her multiplication facts, and I'm drilling her, like, every night because I know how important they are because we use them all the time. So I know that because they're both even, they're automatically going to divide by 2. So I'm just kind of using number sense. When I looked at this one, I knew that 4 went into both because I'm thinking about dollars and quarters. They're what? Say that again. Well, those are my tricks. That's what I'm doing in my brain as I'm doing it. I look for things that are even multiples of 5. That always gets me started. But yeah, a lot of it's just I'm good at multiplication, and that's helpful. All right, let's go on. This slide I put in there, so if you need like a detailed, where did all this come from, that's all this slide's in there for, so we're not going to do anything with it. It's just there in case you need it. Okay, go to that slide. All right, so in digits, it's going to say, write the ratio as a fraction, decimal, and percent. Okay, and they're going to give it to you like this, and I knew like Lily just gave me a face. This is exactly what I just did with you. Exactly the same thing. Okay, so this is, remember we talked about ratios and rates and unit rates. Remember, ratios just meant comparing two things that have the same units. Okay, how would I write this as a fraction? 57 over 60. Remember, a long time ago, we talked about writing it 3 ways, and we used dot, we used the fraction, and we used the word 2. Okay, how would I write this ratio as a decimal? You would just divide it, right? So 57 divided by 60. So 57 divided by 60 is 0.95. Okay, so 0.95 or 0.95. Okay, and the ratio as a percent would be 95%. Okay, so I just wanted you to be comfortable when Digits gives it to you in that form. That's what they're asking for. Same thing we just did, just not as a table. Okay? All right. This one grosses me out because I don't really like tongues. But they said, a research article claims that 64% of people in the United States can roll their tongue. Can you guys roll your tongue? I can. Is there anybody who can't? Okay, so that's 1. Anybody else? 2? 3? So there's 3 people. 4. Jenna can't? Well, that would definitely be over 60. Cassie can't? You can't do yours either? Okay, so there's a few. That is a genetic thing, by the way, that you can roll your tongue. It's a real thing. Okay, so suppose your school has 250 students. Write the ratio of students who can roll their tongue. Remember we talked about that magic word 2? That separated out the 2 parts? To the total number of students. Okay, so how are we going to figure out 64% of 250? This is back to topic 3, which you guys did very poorly on. We're going to figure out 64% of 250. I can use some multiplication. Kathy? Well, the only thing is that I'm going to need it students to students. I know that there's 250 students. Okay, so here would be my, to the total number of students would be 250. But what part am I missing? I'm missing how many are the 64%, how many kids. Okay, so I taught you multiple ways in topic 3. I think we used percent equation. I want to say we used percent proportion. Or you could just use general problem solving. Is it starting to ring a bell? No? So we would have had percent proportion, which we had percent over 100, and part over whole. We did this. We also did the percent equation, which was, let's see, percent times the whole equals the part. Is that ringing a bell now that you see it again? That was back from topic 3. Okay, so if we want to use, how about percent equation? What's the percentage? Okay, but we have to change it into a decimal to use it. We know how to do that, right? What would that be?
0.64.
Or you could do 64 over 100. That would be the same thing. Okay, times, do we know the whole amount? 250, and that will give us the part that we're looking for. Okay, so what is, can you guys do that for me? What is 0.64 times 250?